Hello and welcome back to another video. This one is on the self-ionization of water. So let's start with an equation. So say we had water plus water. That would give us H3O plus OH. So in this equation, it makes a constant because of properties of water. So there's Kw, which is the ion product constant of water. So basically what that means is that Kw equals the molarity of H3O plus times the molarity, that's what the brackets mean, molarity of OH equals 1.0, repeating forever and ever, 1 times 10 to negative 14th molar squared. So because of how water breaks down, we have this constant now that we can use to do problems, because what else would we do with it? So you can use it to find either the concentration of the hydroxide ion or the concentration of the hydronium ion. This one's hydronium. This is hydroxide, obviously. Hydroxide. So this can give you the concentration. It can also, based on that concentration of these ions, you can figure out if you have an acid or base. So if the molarity of the hydronium ion is greater than 1 times 10 to the negative 7, that's an acid. And then if the molarity of the hydroxide ion is greater than 1 times 10 to the negative 7, that's a base. So let's see how we use this fun formula we just discovered. So, say the question asks us to find the molarity of hydroxide when the molarity of hydronium equals 6.80 times 10 to the negative 10th molar. And then is it an acid or a base? So these are super simple. So how you're going to set this up, the molarity of whichever one you're trying to find equals, because we know the constant is just the molarity of hydronium times the molarity of hydroxide. To find only one of them, we can just divide and put that on top. So we can just put our constant number, 10 to the negative 14th m squared, over whatever we're given, and then plug it in our calculator, round to 3 sig figs. Don't go off this one. The one's exact. Go off of what's given your problem. So we have 3. That'd be 4.76. Oop, nope. I read the wrong question. This would be 1.50 times 10 to the negative 8th molar. So that's the molarity of the hydroxide ion. So now it wants to know, is it an acid or base? Well, because up here, my screen moves. Okay, because of right here, these are negative exponents. So remember, we're going negative. We have a hydroxide. So this number would be bigger than this number. So it is a base, because we're working with hydroxide. So let's do one where we find the molarity of the hydronium ion. So again, that's just your constant. It's 14, not 11. 14 m squared, because you have 2 molarities. And then our hydroxide this time is 5.678, 10 to the negative 3rd. So we have 466, that gives us 4. Nope, that's a 1 again. I really cannot read today. Or speak apparently. Oh wait, that's 1.761 times 10 to the negative 12. So that would be the answer. So now we need to know if it's acid or base. So when you're finding hydronium, if it's greater than this, it's an acid. Well, this is obviously not greater. Negative 12 is not greater than negative 7. So this would be a base, which means another way you can think of it is if you look here, you have more of this of the OHs than you do of the H3Os. So that since there's more of those, it would be a base because you have more of the negative of the anions than the cations. Here you have more of the anions than the cations, so it's a base. So that's how you figure that out. And that's basically it for self-ionization of water. Thank you so much. Let me know if you have any questions.